On the morning of 31st May 1916, 250 warships gathered in the North Sea for the largest fleet engagement in the history of naval warfare. Every vessel on both sides, British and German alike, had been designed, funded, and built to a standard set by a single ship. The guns were heavier because of her. The armor schemes were drawn around her specifications. The tactics being rehearsed in every wardroom from Scapa Flow to Wilhelmshaven had been developed in direct response to what she had introduced to the world 10 years earlier. HMS Dreadnought was not there. The ship that gave the Dreadnought era its name. The vessel that had made every other battleship afloat obsolete in a single year was in refit at Sheerness when the fleet she had created went to war without her at the Battle of Jutland. She had been superseded, not by the enemy, by the logic of the revolution she had started herself. But the real story of HMS Dreadnought is not the story of a ship that arrived too early and left too soon. It is the story of one admiral's gamble with the entire foundation of British sea power, and why the most consequential warship ever commissioned by the Royal Navy spent its most important war watching from the sidelines. By the turn of the 20th century, the Royal Navy had held unchallenged command of the world's oceans for nearly 100 years. The two-power standard, the parliamentary commitment that Britain's battle fleet must equal the combined strength of the next two largest navies, had been policy since 1889. It had cost a great deal of money. It had worked. No foreign fleet had seriously contested British supremacy since Trafalgar. That supremacy was now under threat, not from a single rival power, from a structural problem in the mathematics of naval gunnery itself. The battleships of 1904 were formidable vessels. A typical pre-dreadnought capital ship of that period mounted 4 12-inch guns in 2 twin turrets for long-range engagement, supplemented by a secondary battery of 6-inch and 9-inch guns for closer action. The theory was sound in principle. Different ranges, different guns, different fire. In practice, it was becoming untenable. At the ranges at which modern engagements were increasingly being fought, beyond 10,000 yards, the splashes from mixed-caliber salvos could not be distinguished from one another. A gunner spotting fall of shot from 4 miles away could not determine which caliber had just landed short. Correction was guesswork. Accuracy collapsed. The mixed battery, the foundation of every major fleet's gunnery doctrine, was beginning to look like an expensive compromise that satisfied no range well. The man who saw this most clearly was Admiral Sir John Arbuthnot Fisher. He had been appointed First Sea Lord on October the 20th, 1904. He was 63 years old. He had risen from naval cadet at 13 to the highest professional office in the Royal Navy, and he had spent 30 years forming opinions about naval warfare that most of his contemporaries found alarming. Fisher believed that speed was armor, that a ship fast enough to choose when and at what range to fight was better protected than any vessel buried under steel plate. He believed that the mixed battery was obsolete. He believed that the Navy was spending enormous sums maintaining ships that would be useless in the next major fleet engagement, and he was not temperamentally inclined to wait for consensus before acting on that belief. In December 1904, 6 weeks after taking office, Fisher convened what he called the Committee on Designs. Its membership was carefully selected: younger officers, naval architects, gunnery specialists, and civilian engineers who were known to be receptive to unconventional thinking. The committee's task was to evaluate proposals for a revolutionary new capital ship, one armed entirely with heavy guns of a single caliber, driven by a new propulsion system that had previously been used only in lighter vessels, and built fast enough to outrun anything it could not outgun. The strategic driver was explicit. In the spring of 1904, the Italian naval engineer Colonel Vittorio Cuniberti had published a theoretical design for what he called an ideal battleship in Jane's fighting ships: 10 heavy guns, high speed, uniform armament. The Italian Admiralty had rejected it as too expensive. Fisher read it and recognized it as the specification he had been writing in his own mind for years. Germany, under Gross Admiral Alfred von Tirpitz, was expanding its battle fleet under the naval laws of 1900 with a deliberate target: to build enough capital ships to make a war with Britain prohibitively costly. By 1904, Germany had 16 first-class battleships either in service or under construction. The margin that had sustained British supremacy was narrowing, budget review by budget review. Fisher's response was not to build more of the same. It was to make the existing race irrelevant. The Committee on Designs reported in February 1905. Its recommendation was unambiguous: a battleship of 17,900 tons, armed with 10 12-inch guns in 5 twin turrets, driven by Parsons steam turbines to a sustained speed of 21 knots, 3 knots faster than any contemporary capital ship, and capable of bringing 8 of those heavy guns to bear in a broadside simultaneously. The uniform main battery would eliminate the spotting problem entirely. A Parsons turbine, a technology previously installed only in destroyers and fast passenger liners, would replace the reciprocating piston engine that shook itself to pieces at sustained high speed, causing the vibration that made accurate long-range range-finding impossible. The Admiralty requirement carried no formal staff designation number in the conventional sense, but the specification demanded what the period's engineering community considered close to impossible: a displacement exceeding anything currently in service, the most powerful armament ever fitted to a British warship, a turbine installation of unprecedented scale, and a construction timeline intended to shock the world. Fisher intended to lay the keel in October 1905. He intended the ship to be at sea by Christmas 1906. Naval architects across Britain and Germany alike considered this an act of institutional theatre. It was not. It was a strategic calculation. British yards were more efficient than any competitors. If the new ship could be placed in service before any rival power had time to respond with a design of their own, Britain would hold an unassailable lead in the only class of warship that would matter in the next war. On the 2nd of October 1905, the keel of the ship designated Dreadnought, meaning fear nothing, was laid at HM Dockyard, Portsmouth. Vickers, Sons, and Maxim supplied the gun mountings. Charles Parsons' company delivered the turbine machinery. The workforce at Portsmouth expanded accordingly. The cost of the vessel, by program records and contemporary Admiralty estimates, ran to approximately £1.8 million, roughly £250 million in today's values. Exact figures remain subject to archival review, but the order of magnitude is not in dispute. She was launched on the 10th of February 1906 by King Edward VII. She was commissioned into the Royal Navy on the 2nd of December 1906, 366 days after her keel was laid. To understand what HMS Dreadnought represented, it is necessary to understand what she replaced and why the replacement was so total. A pre-Dreadnought battleship of 1905 was not an ineffective warship. HMS Lord Nelson completed the following year, displaced 16,500 tons, mounted 4 12-inch guns and 10 9.2-inch guns, and was considered by the Admiralty to be a capable vessel. She cost approximately £1.6 million. She was, by every measure available at the time of her design, a sound and powerful ship. She was obsolete before she entered service. Dreadnought's primary innovation was the uniform main battery, 10 12-inch Mark 10 guns arranged in 5 twin turrets. 3 turrets were positioned on the center line, 1 forward, 2 aft. 2 wing turrets sat on either beam, capable of firing forward or broadside. In a full broadside engagement, 8 guns could bear simultaneously. This was double the heavy gun broadside of any pre-Dreadnought afloat. More importantly, because all guns were identical, the fall of shot was identifiable. A spotter 4 miles away watching 8 12-inch shells land in a pattern could correct range and bearing with confidence. The problem that had defeated mixed battery gunnery at long range simply ceased to exist. Each 12-inch Mark 10 gun fired a projectile weighing 850 pounds to a maximum range of approximately 16,000 yards, just over 9 miles. The muzzle velocity was 2,825 feet per second. At combat ranges of 10,000 to 14,000 yards, the kinetic energy of a single shell striking a ship's waterline belt was sufficient to defeat any armor plate then in production. Against a pre-dreadnought, the gunnery balance was not competitive. It was categorical. The second innovation was the Parsons turbine. Charles Parsons had demonstrated steam turbine propulsion at the 1897 Spithead Naval Review when his experimental vessel Turbinia ran at 34 knots through the assembled fleet, uninvited, unstoppable, and comprehensively embarrassing to every reciprocating engine warship attempting to intercept her. By 1906, turbines had been fitted to destroyers and the fast mail liner HMS Victorian. No capital ship had yet carried them. The engineering challenge of scaling the technology to a vessel of nearly 18,000 tons was considerable. When it was solved, the result was a ship that could sustain 21 knots against the 18-knot maximum of first-class pre-dreadnoughts without the catastrophic vibration that had made long-range gunfire from high-speed reciprocating engine ships functionally impossible. Parsons' turbines eliminated the mechanical conflict between speed and accuracy at a single stroke. The test program ran through the spring and summer of 1906 off the Nore and in the Channel. 3 primary concerns required resolution: the structural integrity of the hull under the shock of an 8-gun broadside, a force of approximately 20,000 tons of recoil energy transmitted simultaneously, the reliability of the turbine installation at sustained high revolutions, and the effectiveness of the Evershed fire control system that would coordinate the guns across 5 separate turrets. All 3 concerns were addressed. The broadside trials at Portland revealed acceptable hull deflection within design parameters. The turbines proved more reliable than any reciprocating installation of comparable power. The fire control system, though primitive by later standards, demonstrated that a uniform battery could be directed as a single instrument from the spotting top with a precision no mixed battery ship could approach. What made the design politically indestructible, and this is the point Fisher's critics consistently missed, was not the technical specification alone. It was the combination of technical superiority and production speed. Fisher had understood that the value of the dreadnought lay not merely in what she could do, but in when she would exist. The ship that set the new standard before any rival could respond would force every competing navy to scrap its existing program and begin again. Britain, with the largest and most efficient shipbuilding industry in the world, would be better placed to fight that race than any opponent. The decision was made. The program had its champion. Dreadnought commissioned as flagship of the home fleet at Portsmouth in December 1906. She was joined in the Atlantic Fleet and the Channel Fleet in 1907 by HMS Bellerophon and HMS Superb, the first ships built to the new standard she had established. The first battle squadron, working up in the Solent, now contained vessels against which no pre-dreadnought capital ship anywhere in the world could offer a credible engagement. The strategic calculation at the moment of commissioning appeared to have been proven entirely correct. The immediate operational consequence of Dreadnought's commissioning was not the strengthening of the Royal Navy's battle fleet. It was the instantaneous obsolescence of every battle fleet in the world, including Britain's own. This is the central irony of Fisher's revolution, and it must be stated plainly. In 1906, the Royal Navy possessed 53 pre-dreadnought battleships. They were the most powerful pre-dreadnought fleet in existence, representing several decades of investment and the accumulated industrial capacity of Barrow, Devonport, Pembroke, Chatham, and every major private yard from Clydeside to the Thames. The moment Dreadnought commissioned, all 53 of those ships became, in the language of the gunnery tables, pre-dreadnoughts, a term that had not existed 12 months earlier and which now carried the implication of the tactically outclassed. Germany had a smaller fleet of comparable pre-dreadnoughts. The United States had fewer still, but the relative advantage Britain had built up over 30 years in numbers, in quality, and in experience, was reset to zero. Every navy in the world now started the new race at the same line. Germany responded within 3 years. The Reichstag passed the amendment to the naval law in 1908, accelerating the German dreadnought program. Admiral von Tirpitz laid down Nassau in 1907, Germany's first true response to the new standard, and within 2 years the rate of German construction had reached a pace that alarmed Westminster. The parliamentary crisis of 1909, the so-called "We Want 8" controversy, when the Admiralty demanded 8 dreadnoughts in the current year's building program against the Treasury's offer of 4, was a direct product of the arms race Fischer had initiated. By 1914, Britain had commissioned 29 dreadnoughts and battlecruisers. Germany had 17. The lead was real. It was also costly in a way that the pre-war exchequer felt severely. Dreadnought herself served as flagship of the home fleet from December 1906 to 1911, operating primarily in the North Sea and on exercises in home waters. She participated in the great fleet reviews at Spithead and Torbay that Fischer used to demonstrate British naval strength to visiting foreign delegations. She exercised with the 1st Battle Squadron, refining the tactical doctrine that would govern fleet engagements in the coming war. In 1912, she was transferred to the 4th Battle Squadron. The Parsons turbines proved their worth in sustained operations. At the 1907 fleet exercises, Dreadnought logged 21.6 knots on measured mile trials, marginally above her specification, without the mechanical failures that had plagued reciprocating engine ships of comparable displacement on extended high-speed runs. The North Sea in winter is not a tolerant testing environment. She performed without structural incident. Her construction inspired a direct lineage of Royal Navy capital ships that within 5 years had already begun to exceed her in every dimension. HMS Bellerophon, commissioned in 1909, displaced 18,600 tons. The Orion class, laid down in 1909 and 1910, stepped the main battery up to 13.5-inch guns, a caliber increase that made Dreadnought herself begin to look modestly armed in the context of her own legacy. The Queen Elizabeth class, laid down from 1912, displaced 27,500 tons fully loaded and mounted 8 15-inch guns. The progression from Dreadnought to Queen Elizabeth had taken 6 years. The original ship had already passed through 2 generations of obsolescence. The battle cruiser, Fischer's parallel concept, a ship with the armament of a dreadnought and the speed of a cruiser, trading armor for knots, had produced HMS Invincible, HMS Inflexible, and HMS Indefatigable. These ships, operating as the 1st battlecruiser squadron at Rosyth under Vice Admiral Sir David Beatty, were faster than any capital ship Dreadnought could engage. They were also, as Jutland would demonstrate, dangerously under-armored for the role they were asked to fill. Outside British waters, the ripple of Dreadnought's revolution reached every significant naval power within a decade. The United States Navy's USS South Carolina and USS Michigan were laid down in December 1906, 2 months after Dreadnought commissioned, and completed in 1910. The Imperial Japanese Navy accelerated its own program. The IJN Kawachi, commissioned in 1912. The French Marine Nationale laid down the Courbet class in 1910. The Russian Imperial Navy ordered a new Baltic Fleet dreadnought program that consumed resources the Empire could not afford. The Austro-Hungarian Navy, the Italian Regia Marina, and even the Brazilian and Argentine navies, buyers of British-built capital ships, commissioned or contracted for dreadnoughts before 1914. Dreadnought's name had become a noun in every language in which naval affairs were discussed. In the North Sea, from 1914, the Grand Fleet settled into the strategic posture that would define the naval war. A distant blockade maintained from Scapa Flow in Orkney, designed to deny Germany access to the Atlantic trade routes without exposing the fleet to the minefields and submarine concentrations that made a close blockade suicidal. The 4th Battle Squadron, to which Dreadnought was assigned at the outbreak of war, formed part of the screen protecting the Orkneys and monitoring the northern approaches. The work was unglamorous. Long patrols in heavy weather, sweeping a grey and featureless horizon, watching for a German sortie that was not coming. Then, in March 1915, HMS Dreadnought did something no battleship had ever done before, and no battleship has managed since. On the morning of the 18th of March 1915, the German submarine U-29, commanded by Kapitän Lieutenant Otto Weddigen, the most celebrated U-boat commander of the early war, the man who had sunk 3 British armoured cruisers in a single engagement in September 1914, was manoeuvring on the surface in the Pentland Firth, north of Scotland. U-29 had fired a torpedo and was watching the result when lookouts aboard HMS Dreadnought sighted the conning tower at a range of roughly a mile. The officer of the watch ordered full ahead and put the helm over. Dreadnought struck U-29 amidships at 21 knots. The submarine was cut in half. There were no survivors. The most powerful battleship in the world, a ship constructed to fight at distances beyond 10,000 yards with the heaviest naval ordnance then in service, had achieved its single confirmed kill of the entire war by collision. The Admiralty noted the event without visible irony. But by the spring of 1916, the strategic situation had shifted in ways that left Dreadnought increasingly marginal to her own conflict. The super dreadnoughts of the Queen Elizabeth class and the Iron Duke class were now the core of the Grand Fleet's battle line. They mounted heavier guns, carried heavier armor, and steamed at comparable or greater speed. Dreadnought's 10 12-inch guns, revolutionary in 1906, were now the lightest main battery in the fleet. She had been assigned to the 3rd Battle Squadron at the Nore, a reserve formation, in 1916. When the Grand Fleet sorted to meet Shear's High Seas Fleet at the end of May 1916, the 3rd Battle Squadron was not included. The ship that named the battle was in a dockyard berth at Sheerness. The Dreadnought did not die by ministerial statement or Treasury veto. There was no Commons announcement, no white paper, no cancellation hearing before the Public Accounts Committee. Her end was quieter and, in some respects, more instructive than any formal cancellation. She was overtaken by the consequences of her own existence. The process was visible from almost the moment she commissioned. Fisher had understood that Dreadnought would be superseded. The logic of the revolution demanded it. A design that compelled every competing navy to begin the race again from zero would itself become the minimum standard, not the maximum achievement within the span of a single building program. What Fisher had not entirely calculated was how rapidly his own navy would exceed her. The Orion class, laid down in 1909, carried 13.5-inch guns. Dreadnought's 12-inch battery was no longer the heaviest in the fleet. The Iron Duke class, laid down in 1912, carried the same caliber with a more advanced fire control system. The Queen Elizabeth class, laid down from 1913, mounted 8 15-inch guns, a weapon that fired a shell weighing 1,920 pounds, more than twice the weight of Dreadnought's 12-inch projectile. Against a Queen Elizabeth, a Dreadnought engaging at 14,000 yards would be struck before her own fire became effective. The mathematics of naval gunnery, which had made pre-dreadnoughts obsolete in 1906, now made the original dreadnought herself increasingly marginal. At the outbreak of war in August 1914, Dreadnought was still a commissioned fleet unit, flagship of the 4th Battle Squadron. She was, however, no longer a first-line asset in any serious engagement planning. The Naval Staff's battle orders for a fleet action placed the Iron Duke class and the Queen Elizabeth class at the center of the line. The 4th Battle Squadron, built around older dreadnoughts, including Dreadnought herself, occupied a secondary position. The irony deepened as the war progressed. The 4th Battle Squadron was transferred to the Nore in 1916. Dreadnought received an overhaul during which additional anti-aircraft armament was fitted, 24 and 27 76mm quick-firing guns, an acknowledgement that the threat environment had changed in ways that no one at Portsmouth in 1905 had anticipated. The submarine and the aircraft, not the opposing battle fleet, were reshaping the tactical landscape. The armament changes were cosmetic. They did not alter her fundamental displacement from the first line. After Jutland, the calculus was complete. The battle had demonstrated, at a cost of 14 British ships and 6,094 dead, that the dreadnought fleet action Fisher had designed the Navy to fight was neither strategically decisive nor operationally straightforward. The High Seas Fleet had escaped. The Grand Fleet had lost more tonnage. The distant blockade continued. Dreadnought continued her patrols in home waters, part of a fleet that had established mastery of the North Sea without being able to translate that mastery into a war-ending engagement. She was paid off in July 1919. The war was over. The Washington Naval Treaty of 1922, negotiated between Britain, the United States, Japan, France, and Italy, imposed formal limits on capital ship tonnage and construction that the post-war fiscal position made, in any case, economically inevitable. The Admiralty did not contest the scrapping of Dreadnought. There was nothing left to contest. On 9th May 1921, HMS Dreadnought was sold to T.W. Ward of Inverkeithing for breaking up. The price was £44,000. In December 1906, she had been worth every pound of approximately £1.8 million. In May 1921, she was worth £44,000 as scrap steel. She had been obsolete for years. The world had moved on. The word remained. The sale was agreed. The papers were signed. The tugs took her north. 15 years, one submarine, not a single shot fired at a surface enemy. The most revolutionary warship in history had fought the least remarkable war of any ship her size. The physical ship was gone by 1923, broken down at Inverkeithing into steel plate and scrap. The name outlasted the hull by decades. What Dreadnought left behind was not a design, it was a standard of measurement. From 1906 until the end of the battleship era in 1945, every capital ship constructed by every naval power in the world was evaluated against the benchmark she had established. Pre-dreadnought or dreadnought, before or after. The word entered the dictionaries of every major language as a common noun. In English naval parlance, dreadnought ceased to be a proper name within 5 years of the ship's commissioning. It became a category, the same process by which Hoover became a verb and thermos became a noun. HMS Dreadnought achieved something that almost no manufactured object achieves. She named an era she had already passed through. The technologies she introduced proved more durable than the ship herself. The Parsons steam turbine, scaled and refined across the following decades, propelled every major British capital ship through both world wars. HMS Warspite, HMS Duke of York, HMS Vanguard, the last British battleship, completed in 1946, all depended on the turbine propulsion that Dreadnought had first demonstrated in a capital ship hull. The uniform heavy-caliber main battery, the fire control philosophy, the armored belt geometry, all of these principles were carried forward, refined, and scaled upward through the super dreadnoughts, the treaty battleships, and into the last generation of British capital ships. The doctrine Fisher had built around her, speed as primary protection, offensive firepower over passive defense, the fleet concentrated in home waters rather than dispersed across an empire, shaped Royal Navy thinking through both world wars and into the nuclear age. The decision in 1960 to name Britain's first nuclear submarine HMS Dreadnought S-101 was not merely a piece of institutional sentiment. It was a deliberate statement that the tradition of strategic technological disruption, of designing a vessel that reset all existing assumptions about naval power, had found a new expression in the Polaris era. The successor class of Trident-armed submarines currently under construction will carry the Dreadnought name again. Fisher himself did not see it that way at the end. He resigned as First Sea Lord in January 1915, following the dispute over the Dardanelles operation that also cost Churchill his position. He was returned as First Sea Lord in October 1914 and again forced from office under political pressure. He died in July 1920, a year before his most famous creation was sold for scrap. He did not attend the sale. He did not publicly eulogize the ship. He had spent the war years arguing that the battleship itself was becoming obsolete, that the submarine and the aircraft carrier would define the next conflict, not the capital ship he had created. History, as it often does with prophets, gave him credit for the revolution he had started and confirmed the warnings he had issued about where that revolution would end. The honest verdict on HMS Dreadnought, in the assessment of naval historians, including Andrew Lambert and John Sumida, is this: the ship was a strategic masterstroke that achieved its immediate tactical objective, forcing every rival navy to begin again at the same starting line, at the cost of an arms race that exhausted the British exchequer in the decade before the war, and that Britain, despite winning, could not afford to repeat. The revolution was real, the price was real, and the paradox that Fisher understood and accepted was real. You cannot maintain supremacy by building a ship that makes all existing supremacy worthless. You can only build it and hope you build the next one faster than everyone else. For 35 years after 1906, every naval war plan written in every admiralty in the world was written around the logic HMS Dreadnought had imposed. That is the measure of what was achieved at Portsmouth in those 366 days. If you found this history valuable, give the video a like. It is the single best signal you can send this channel. And if you want more stories about the ships, the aircraft, and the decisions that shaped British military power, subscribe to UK Defence Archive. We will see you in the next one. Music. Somewhere off the Pentland Firth, on a cold morning in March 1915, HMS Dreadnought turned at full ahead. All four shafts driving, 23,000 shaft horsepower through Parsons turbines, 21 knots and rising, and ran a German submarine down. It was not the war she had been built to fight. It was the only war she was given. She struck amidships, and the sea closed over U-29 in less than a minute. The most powerful battleship in the world, built to engage fleets at 10,000 yards, had made her single mark at ramming distance, and the ship that had changed everything sailed on north into the grey.